So the last task we're going to look at today is for a cross drain. Now this exercise is going to be a little bit contrived, but I think that you'll get the understanding of the process. At least I hope you do. I've opened a new DGN file for our cross drainage, and you'll notice in the contours I've turned these on for guidance, but it also points out for this particular piece of data the terrain model is pretty rough. And so let's start, and I'm just going to build a cross drain that comes across right there. And so let's start by building our cross drain, and I'm just going to place two head walls. And I'm going to do something really simple here, honestly, with straight head walls. And so I'll just do something like that. And I'm going to use a 2-foot offset from the ground because for this particular type of head wall, a 2-foot offset gets you pretty well underground without much risk of exposing the pipe. And then I'll put another one over here, let's say. And the only reason I had those contours turned on was to help guide me where these slopes were at for the railroad, and so I'll turn those off now. Now let me make a quick check here to make sure 96.12, and make sure I don't have this guy going uphill. 9605, that's pretty flat. Let's pull it downhill a little bit. So now we've got a little more slope on that pipe. And then I'm just going to put in, let's put in the smallest pipe that we have, because we're actually going to do a design here. Okay. Now, what we've created here now is really just a tiny drainage network, and so let's actually review the properties of this cross drain. Because what we want to do a culvert analysis. And so down in the properties for this pipe, then there is this a property that is this a culvert, and we want to turn that to true. It is a culvert. And basically that switches the underlying computations to use an HY8 type computation instead of a storm drain network. And so for the head wall then, we can define what are the entrance characteristics, and so we'll say this is a groove end with a head wall, and then the downstream is a square edge with a head wall. And so that gets us set up then to do a computation for a culvert. Now let's also put in a drainage area. And so what I want to do then is I'm just going to use pick points, and so let's say that the area that this culvert is draining is something like this. And it flows into that head wall. Okay, so now we have our drainage area, and we also have our culvert created. Now let's one of the things I didn't mention, let's take a look at these two head walls. I used the same feature definition, but notice that one of them is set to inlet and the other one is set to free outfall, and that's because of the direction that I drew the pipe. I drew it from up here to the upper left down in this direction, so that defined whether these are inlets or outlets. Now the other thing that we're going to need is we're going to need a channel that comes out the end of this, and probably need channels on both ends, but I'll just show on one side. So what I'm going to do, I'm going to run my channel actually off the terrain model here, because the ground is actually not suited for a channel here. So I just want to, so 92.5, and so let's place our the end of our channel at say 92. Now I'm going to use a feature definition here for a generic outlet. Okay, because it's not really a structure here. It's just a holder for the end of the channel. And so I'm going to place its elevation at, what does I say, 91.5. Okay. And in 3D we actually get nothing, but in 2D we get this just generic indicator of a node. Now we want to connect a conduit from this outlet to the outfall of the ditch, and so let's change our feature definition, one that I have for a V-ditch channel, and so it will go from there to here. Now let's take a look at what we have here so far. In 3D we really have nothing, just a line really. But also what happened, let's take a look again. Remember when we looked at these properties, this was a free outfall earlier. Now you'll notice that because we created this piece of channel, then the boundary condition changed to intermediate, because it's actually the transition element from the pipe to the channel. And then if we look at this one out here, then this one has become the free outfall. And so that's just part of the knowledge that you'll need to have. Now we should be then ready to do some computations then. And so let's go into our computations. We are going to be designing this time. We want to determine the size of this cross drain pipe. So let's see then how this will work for us. So if you were looking closely, then you may have seen in 3D that the pipe changed. Remember, we're designing here, and so it resized the pipe to carry the water. And so let's look at the properties and let's see what size pipe that we came up with. And so remember, we laid it out just as a 12-inch. That's the smallest in our library. And so it's determined that we need an 18-inch to carry the water properly. And so it's designed to that for us. Remember our analysis profile area earlier, that this is another good place where that analysis profile will help us. Now since I've only got two segments here, I'll just pick them instead of auto create. So if we take a look at that analysis profile, then we can see here's our culvert going under the railroad, and then here is the channel that carries the water out, which is eventually to a pond in our next exercise. Now the last thing we need now is we actually want to see a 3D model of this channel. Actually, first I need to look at the profile. A little bit of a trick here, so close that. Now if this profile was not suitable, then you could redesign whatever profile that you want right here, but this one we're going to say is okay. And now we just want to turn on the trench, because the way that we're creating the physical model, the 3D model, is with a trench, and so I'll toggle that on, and there is our grading for the channel itself.